Okay, in the first example that I have here, it's about a mixture of nitrogen gas. It says it's collected over water at a temperature of 25 Celsius. What is the pressure of nitrogen gas if atmospheric pressure is 789 millimeters of mercury? Millimeters of mercury. And the partial pressure of oxygen gas is 113 millimeters of mercury. So, we're going to have two different kind of exercises for partial pressure. Okay, we're going to have two different kinds. One that is going to be like these ones that are collected over water. When that occurs, you need to know that it's about a vapor. Okay, that is collected over water means water vapor. So water vapor is going to be one more gas in the mixture. Okay. So, how many gases are in this mixture?
3.
Okay, I have nitrogen, I have oxygen gas, and of course, because it says collected over water, I know that I have water vapor. Okay, so because I have three different gases, I'm going to have three different pressures. So I'm going to have my pressure of nitrogen, my pressure of oxygen gas, the pressure of water. Okay, remember that in this case water is at 25 degrees Celsius, so it's going to have a specific pressure. Now, what is the pressure of nitrogen? It doesn't say, right? It says what is the pressure of nitrogen gas. That is exactly what I need to find. Okay, I need to find nitrogen, so this one is going to be my unknown. The pressure of oxygen is given as 113 millimeters of mercury. Okay, and the pressure of water is at 25 degrees Celsius. Can you please tell me what is the pressure of water in millimeters of mercury at that temperature, please? How much?
3.8.
26.8.
23.8.
23.8. Wait. 23.8. These are millimeters of mercury. Though in the table it shows just the torr. Okay? But remember that torrs and millimeters of mercury are the same. Okay? They are equivalent. They are equivalent units. Now, what is the total pressure of the mixture? What is the total pressure of the mixture? 789 millimeters of mercury. So I need to find the partial pressure for nitrogen. So according to the Dalton's law of partial pressures, I have the pressure of the mixture is equal to the pressure of all the gases. I have nitrogen, I have oxygen, and I have water vapor. Okay, and I'm looking for nitrogen. So I'm going to adapt this formula and I will isolate for nitrogen. So this is going to be, this one is adding, it goes to the other side to subtract. Also this one is adding, it's going to go to the other side to subtract. So the pressure of the mixture minus the pressure of oxygen minus the pressure of water vapor is equal to the pressure of the nitrogen gas that I'm looking for. Now all I do is I make substitution of my given, the total. To make all the substitution, I need all my units to be the same. In this case, all of them are the same, so all I need to make is the substitution of the given. The mixture, that is 789 millimeters of mercury, minus the pressure of water, that is 113 millimeters of mercury, minus the pressure of water at 25 degrees Celsius, that is 23.8 millimeters of mercury. All this is equal to the pressure of my nitrogen gas that I am looking for. How much is this? 652.2 millimeters of mercury. Okay, sorry. Okay, that will be it for a sample collected over water, okay, over water vapor. Now, another kind of example that we're going to have for partial pressures is when we just have a mixture of gases, okay? Now, take a look. Even if in this exercise they're giving me a temperature, the problem doesn't say that it's collected over water, okay? So water vapor is not going to be part of the problem. So it says a mixture of argon, nitrogen, and helium gases is at a temperature of 25 Celsius. What is the pressure of the nitrogen gas if atmospheric pressure is 769 millimeters of mercury and partial pressure of helium gas is 83 millimeters of mercury. Partial pressure of argon is 0.37 atmospheres. So, how many gases I have in this mixture? How many gases I have in this mixture? And argon. Argon, nitrogen, helium. Okay? So I have 3 gases. I'm going to have, therefore, the pressure of my argon, the pressure of my nitrogen, and the pressure of helium. Because this problem, I repeat, because this problem doesn't say that it's collected over water, you are not going to consider water vapor here, okay? Just the gases that are mentioned in the problem. The problem is asking you to find what? I need to find the pressure of nitrogen gas. This is going to be my unknown, okay? Now they're giving me atmospheric pressure. Atmospheric pressure is just another way to say that this is the total pressure of the system, okay? So the total pressure, or the pressure of the mixture, is equal to 769 millimeters of mercury. It says the partial pressure of helium gas is 83 millimeters of mercury, and partial pressure of argon is 0.37 atmospheres. So, first thing I notice is that I have millimeters of mercury, and ATM. So I need to convert, because in order, even if in this equation we all add, or we just add or subtract, remember, you can add only those terms that are alike. And if I have atmospheres, I cannot add atmospheres with millimeters of mercury. Okay? So I need to convert. So from ATM to millimeters of mercury is, in 1 ATM, I have how many millimeters of mercury? 760 millimeters of mercury. Okay? Chalala, chalala. This is how much. You can write it in the chat. 281.2. Okay, so I have my partial pressure of argon, helium, and the total. So I need to isolate the nitrogen. Okay, so my main equation is pressure of the mixture, or total pressure, is equal to the individual pressures or the partial pressures of the rest of the gases. So I have pressure of argon plus the pressure of nitrogen gas plus the pressure of helium gas. I will isolate nitrogen. Okay, so argon is adding, goes to the other side to subtract. Helium is also adding, is gonna go to the other side to subtract. So you will have pressure of the mixture minus the pressure of nitrogen gas minus the pressure of helium gas equals to the pressure, sorry, I got confused, this one is argon, equals to the pressure of nitrogen. Okay, so what do we do after? Substitution of our given in the same units. Mixture is 769 millimeters of mercury. Argon is 0.37 atmosphere, but converted is 281.2 millimeters of mercury. And helium is 83 millimeters of mercury. This is equal to the pressure of my nitrogen. How much is this? 404.8 millimeters of mercury. Pressure of nitrogen is equal to 404.8 millimeters of mercury. So two different kind of problems, but the general idea of the topic is the same.